You know, Mr. Tesla, I really like the quiet version of you. Yeah, I got to film for a little bit. You want to be quiet? Yeah, you and that demon tail you've got. Gentlemen, I'm talking with my pupper dogs. This is the original box for this gem that's in here. I have no idea what kind of condition it's in. I know next to nothing about this little guy. I know it weighs 44 pounds. This is the lightest thing that I've put up on this workbench in a couple days, it feels like. It feels like. This is a Henry II, or pardon me, a Henry K-2000. The original shipping label says from Henry. It's even got pieces of the OG styrofoam in here. I'm not familiar with this. I'm not going to even pretend like I know anything about it. I'm going to learn about it as we go here, which kind of become a pro at this point. But it's an amplifier. It can't be that complicated. Let's see. Type and function of equipment. This is a K-2000. It is a 2,000 watt PEP 1200 watt normal output, one stage linear amplifier using conductive cooled. Oh no. Conductive cooled, highly linear grounded grid triodes. The K-2000 operates on all amateur bands between 3.5 megahertz and 30 megahertz. Well, it doesn't. That's a lie. It doesn't do 160. Doesn't do 6 meters and doesn't do 70 centimeters and 2 meters. And come on, we're jack of all trades here. Can also be operated outside the amateur bands. Conductive into aluminum heatsink. Blah 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 blah. 100% sideband or CW. 50% key down time, or it literally says key down. Otherwise, 50% operation duty cycle. So if you're on for a minute, got to be off for a minute. 230 volts, 50 hertz, 15 amps, or 115 volts, 60 hertz at 30 amps. Drive power required, 75 watts. Input power, 2 kilowatts. Plate power dissipation, 600 watts worth of heat dissipation. That's awesome. Output impedance, 52 ohms, unbalanced, with an SWR not to exceed 2.1, 52 ohms. Harmonic and other spurious radiations. Secondary harmonics, negative 40 dB. Third order distortion is 35 dBs at full power output. Noise level, minus 30 dB. Those are negative numbers, by the way. Noise level, negative 40 dBs or below. One tone carrier at 1 kilowatt. Previous overdrive from today's high working metering. Dimensions, approximately 6 by 14 by 14. Approximate weight, 36 pounds. Shipping weight, 46 pounds. Front panel controls, multimeters, blah, 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 blah. Rear panels of case, fuse, cord, power cord, and it's got an overheat light. If you get it too hot, it'll turn on. And 2 iMac 8873 grounded grid triodes. 1 6FG6 RF output indicator. I remember when I was in grade school, before I had hair around my schmeckle, before I got the weird fuzz feeling in my crotch that says, ooh, girls are good. Reading in front of my classmates was a scary thing to me. And now I stand out here and do it in front of thousands of you and don't care. Boy, how times have changed. Gentlemen, let's take this Henry K-2000 out of its original OG box, which probably belongs in a museum someplace, and let's take a look at it. What do you think? She's kind of a leaner. She leans to one side. Pull it out of the box. Believe it or not, those are the stock OG rubber feet. That's rubber. back harder than the backside of my head. They have jiggled off in shipping. This is our band control knob, 80. Oh, a little stiff. That's going to need some lube, especially getting in the 80 meter position. Oh, wow. It's got one knob. Two knobs. Two knobs. Do-do. 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 Cool little display there in the back. Oh. Doesn't look too bad. I'd say it's been in a relatively smoke-free environment. Cutesy little access panel over here, which allows us access to our fuses and our ALC adjust. ALC adjust, fuse, fuse, and fuse. I bet you it's bias, and these are our 110 fuses. That's cool. It's got a ground nut on the back. Got ourselves a ground nut on the back, output coax, key and relay, ALC output, and a BNC adapter. Well, let me go get my BNC to PL259 or SO239 adapters. On the back here, let's go look at the serial number, which is 36-114. And it says it's set for 240 volts. I'm assuming behind here is an access panel for a voltage conversion. And it's got a 230 volt plug. But being the business to which that I am, I don't take anything for granted. It's like the old Russian proverb that was adopted by Reagan back in the 80s. Trust, but verify. Yeah, the Russians said it first, by the way. Okay. Pretty straightforward. Yes, I'd like to look at the high voltage connection in the back. Low voltage connection. Do-do-do. Do-do-do. I seen a post in my group just last night, and it was a gentleman that was wanting to learn how to read schematics. And he goes, I don't know anything about electronics other than what I've watched in BBI's videos. I remember a time when I was a very young man, that was the same statement that I made to myself. I don't know nothing. How do I read these? Well, now this is just kind of like looking at a book and reading words. But there was a time where this was very hard. And let me explain it to you like this. It's like math. Okay? Math is hard for everybody. Well, learning schematic symbols is hard for everybody. You just have to do it and just have to practice. You know, with the living in the world that we live in today, all you got to do is go download the information and repeat it to yourself a bunch, and eventually you'll learn it. Or have enough strong... The problem with me is, if I don't have a really strong desire to learn something, I'm not going to learn it. My wall, in my brain, I just have a wall that gets put up. So, have faith. And you know, if you don't know a symbol, like we're sitting here, we're looking at this switch here, okay, which feed another set of switches, which is going to a set of diodes. Look. If you don't know the symbol, just stop. And there's many, 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 many parts. This is a lamp symbol that's right here. I think it looks like it's got a set of titties on it. It's a pair of nipples, it looks like, kind of from the side view. It's a lamp. If you don't know, just go Google schematic, electrical schematic symbol diagram. And you'll learn. There's apps for it and everything, if I'm not mistaken. Adjusting input controls. I love this older stuff because they document the frig out of everything. I mean, literally everything. There's always a drawing. It's on page 3. Jumper here for 110, jumper here for 230 volts. Well, let's get the old Kleins out. Let's take ourselves a look for. Then once we verify our voltage, we're going to open it up and take a look at it, and then we'll put our rubber feet back on it. So 110 volt would be this one, and this one all tied together, and then these two tied together, and 220 is going to be that one tied together. So it is set up for 220. Trust, but verify. Before this leaves here, I'm going to replace this cord. This is at the end of its service life, and it is completely not safe. We don't have it poking through yet. We got no copper hanging out yet, but give it a minute. So I can see in my future I got to go to Ace and replace that. But okay, I want to see the inside. Now, I didn't grow up being a kid that liked to mess around with Legos and taking everything apart around the house and putting them back together just because, you know, I like the aesthetics of looking at the outside. Let's take a hot minute and let's rip it apart. Let's go look on the inside. It's a 2-piece clamshell unit. So you have to remove these 2 screws and then remove the screws down the side. It's got an inner lip that slides inside, pardon me. And I can see that it is a standard Henry split case construction, which means the body of the case shares a majority of the internal support structure load. Air inlet for the filament cooling. It's gonna be a lot of screws. But this has all got to come off anyhow because I got to put the feet back on it. So let me go over here and grab my red handled jewels for doing flat blade screws. That is the plate transformer. Legit. Freaking Henry. In Henry's infinite wisdom, they never thought that anybody would ever need to get in here to take the bottom off of this thing. So this is our plate transformer. Frickin' Henry. Okay. They work so good, but they are a pain in the ass to work on sometimes. Let's see what do I got going on down here. Just want to get the feet on it. So where is that? And that is underneath the transformer winding. And that is underneath the wire loom. So wish me luck. Wish me luck. thing is probably worth more in scrap than what it is running, to be honest with you. Because these two germanium blocks or whatever these are is like beryllium oxide, or can't remember the oxide material make right off the top of my head, but I'll remember. If I can remember to throw it in the video, I'll throw it in, put it in here in the comments. I don't see anything in here to give me pause. I've just spent the last like 30 minutes just sitting here staring at it. Everything indexes properly. The only thing that gives me a little bit of heartache is this 80 meter selector, and every single time I'm able to push it through, it seems like it's doing okay. This is a fanless amp, you guys. And the whole idea behind this is that they take a giant hunk of metal mass, and then they put it to a non-conductive substrate that doesn't conduct high voltage but conducts heat. And then they use the radiator on the back. It's... let's see, Dentron made a couple amplifiers like this, if I'm not mistaken. And I had a gentleman come through here a couple years ago that he'd modified his SP220 to take a Russian tube plus a hunk of this material and integrated a huge heatsink inside of his SP220, which I thought was kind of cool. This reminds me of a couple pieces of Collins equipment I've seen. I don't know if it's just the gray on the face or what, but I went ahead and made the amp safe, as far as I disconnected this lead from our plate choke. And I've just kind of tucked it over here out of the way. This thing needs to run for a while because I don't know the last time it was actually operated. And what I need to do is take the cheapest plug money can buy and take this off. And I should probably convert this over to 110. And let's go ahead and bring it up on the old Variac and let it sit and run for a few hours as I sit here and watch it and watch the tubes heat up. The deciding factor on if this thing's going to be worth anything or not is those tubes. These two tubes. If these two tubes, if they're low in output in any way, shape, or form, good luck finding those. I mean, we might find eBay pools or something, but there is a pressure rod that comes from the back of the amplifier here. This is a ceramic insulator. This is a ceramic insulator, and this is a piece of fiberglass with an impregnated nut in the fiberglass, and this pulls the tubes against the heatsink. So to release these tubes, I got to release the pressure on this rod and then pull the tubes out, which I do not and will not do unless it's absolutely necessary. Because those tubes are very, very, very valuable. So this will probably be the only amp I ever ship out of here and leave the tubes inside the amp. They are not designed to come out without a lot of work. And they're not just held in there by the pressure on the pins. They're physically held in there with a bunch of tension and pressure. So let's convert it over to 110. I don't see any safety interlocks up here on the top side of the box, which is very odd for Henry. Those engineers must have retired by the time this came out. Yeah, there's no interlock anywhere here. So let's convert her for 110, bring her up on the Variac. It is 1:17 p.m. And I think we're ready. Variac down. High voltage switch depressed. Let's boot up the old FLIR. Ambient temperature of everything in the box is 72. Could not save no memory card. What are you talking about? There it goes. Okay. So, let's bring it up slow. Let's just sit here and watch it for a minute. There's our 110 volts. It's had an LED conversion to it. Now, There is a phosphorescent screen that's here in the background. Back here. It doesn't matter. We'll come back to that. I think that's a counter indicator, and I don't think that that's working properly. But the $1,000,000 question is, our tubes have lit up. Let's see if we can see them glowing. Negative. They're definitely making heat. See how long the warm-up light takes to click out. And I'm not going to apologize to anybody. This is really important that I bring it up on a variac and it sits here and just runs for a little bit. Because we don't know how long these tubes have been sitting, and I can't just slam high voltage on the tubes. I got to let the getters do the getter things. Low voltage, high voltage. $120. $121. We'll be back. I'm just going to sit here and watch this for a few minutes. Well, I just went over the fine minutia of this box. It's 4:27 in the afternoon. So we let it degas for a couple hours. I rehooked up the high voltage. I didn't get any short overs in the tube. And then I went on to find out why the ready light wasn't working. There was a capacitor in a 12-volt circuit that had leaked. Pulled the cap out, put a new cap in, and now our ready light's working. The only thing I have not gone on and fixed yet is this indicator, which is a relative power output meter. It is not center, nor is that dot matrix or cathode display. I think it's a cathode display of some kind. It's not center, and I got to take that apart. But what I want to know is, does this thing work? So let's go over here. That's 1X. It's just a 1,000-watt slug and peak, and this one's an average 1,000-watt, and this 5-watt slug and reverse. Okay, so I want to see this thing make power. That's it. Now, it will work everywhere. But that being said, I want this to go to a really good home. This is going to go to a ham operator. I really don't want to see this go into the citizens band realm. This is a rare girl. The tubes that are in this thing are good for, they claim, 8,000 to 10,000 hours. Ready to go. 8,000 to 10,000 hours, which is continuous transmission for a year. I pray that these tubes are good, because if they are, they're going to last whoever buys this forever, especially if they put 100 watts in it. So let's go figure out what we're doing for input power here. Ain't nothing. I'm not going to be able to find it that way. Doing about a 10-watt carrier. Okay. Now what I've got this is indexed is for 10. Let's go ahead and let's bring it around to the end of the inductor, because we know 30 megahertz is all the way at the end of the inductor. So I bet you we'll be somewhere around 10 marker. I bet. So 10 watts going in. Let's go see if we can get this thing to build any power. Got this indexed at 10. I think it'd be a fair bet to say we're going to be somewhere in the middle. Oh yeah. Oh. That's what 10 watts. Let's bring our power back down a little bit. Bring it on down there to a couple watts. Now, we're going to hit this with the 955 striker. Do about 90, 80, 90 watts into it. So, let's see what we can figure out here. We are still going through the variac, and yeah, we're still on 110. Okay. Okay, we're off the scale now. Let's go up to 2 times. So that needle all the way in the corner is 2,000 watts. 2,000 watts. So of course the 50, which is in the middle of this scale, is 1,000. So, oh yeah, we're well over that. Oh yeah, full output. Look at the tubes. Look at this tube here. That's cute. Remember, you guys, this was built for a different era. This was back when your transmitters did like 150 watts to 200 watts. Let's go back over here. Remember, we're in 2X. It's about 120 watts worth of drive. Now, I don't want to run it here for very long, but we got to see where the top end of the tubes are with 120 watts of drive. 130 maybe. Oh yeah. 2,000 watts. Like legit 2,000 watts, 1990 or something. That's killing our grids, so that means too much drive. But we're showing that the tubes are capable of doing this output power for a reason. Okay, that's enough of that. It's too much drive. I could sit here and totally fart around with it, with the, you know, the tune and the load and everything. I'd probably get the grid to drop a little bit. Remember, this isn't an air-cooled box. Okay, this is just a pressure inductive cooled box. The point is, and I say this seriously now because I had a guy that like lost his shit here a couple weeks ago. One of my friends that buys for me or helps buy for me. And he says, man, I can't stand that guy. He puts 200 watts in an SB220. And I'm like, yes, so what? That's what they were designed to receive. You guys understand that when the SB220 was built, your standard, like, ham piece of equipment did 160 to 200 watts worth of power. Peak on sideband. I gotta drive it that hard to show it to everybody so we have a standard to measure it against. It's like, this is our maximum output. Well, it's the same thing that's going on here. I'm putting 125 watts in this thing, roughly. Let's measure it exactly so you guys can see. Let me come over here. I'll put that in 1X. So now, it's just going to show you face value of the element. means we're reading at bottom scale. Hello, 1 2. Hello, 1 2 1 2 1 2 1 2 1 2. Hello, 1 2. Hello, 1 2. And about 50 average. But we're done with that. We're done with this little test. This is to prove that everything's okay. Let's go hook it up on 80. Let me come back here and quick disconnect our BNC, because it does have a BNC input on it. We'll shut this garbage down. This is such a rare amplifier, you guys. I know if I sell this to the average CBer and they going, oh, you showed it getting driven with a striker and oh, I gotta have two hot. No, it's not what I'm into here. This has got to go to a ham home where it's gonna get hooked up to like an ICOM 7300 or something like that, where it puts in 100 watts and it will last for decades. All right, so let's go down here. Let's go to AM. AM is gonna, 80 meters is gonna be somewhere around in here. Or maybe somewhere in here, I bet you. Okay, hello, audio. That's all we're putting into it. Maybe 60 watts. Oh, we're not ready. Ready light's not on. Hello, pay attention. While we're waiting, we'll reset. $128 degrees. Okay. So now we're ready. We're in sideband mode, which means high voltage. Here we go. God damn, I guessed that right on the money, didn't I? Okay, let's go ahead and we'll switch over to sideband. So, hello, audio. Hello, audio. So we're no way we're overdriving this thing. Just no way. Hello. Jesus. Okay, I'm gonna have to move you guys because I gotta go back and forth between the peak kit and the not, and with it and not with it. We're gonna go up 2x. We're just gonna leave it there for now. Okay. Currently showing high voltage. We'll come back and we'll look at the grids. Hello, oh, Jesus. Hello, 111. 100 watts makes 1800 watts of power. Look at the grid. Hello, 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 hello. Okay, let's look at the input. Hello, 1 2. Come up here. Hello, 1 2. And what we're looking at is the SWR bridge on the radio. Because this is what most ham guys are going to use, right? Thy fellow amateur operators. Hello, 1 2 1 2 1 2. Hello, 1 2. Hello, 1 2 1 2 1 2. Hello, hello, hello. 1 2. Whew. Okay. Let's go to 40. 40. Throw a little bit of carrier in it. Okay, I'll go back over to sideband. Hello, 1 2. Hello, 1 2. Hello. Looking right here, SWR bridge. Hello, 1 2. Full output, easily. Easily. Now, just put it through a hard cycle. Yeah, we're at 194 degrees and falling. There. Give it just a cushion of air. Just a little cushion of air. Because the hardest you'll ever be on the tubes is trying to figure out where this tunes. So for 80 meters, it's going to be 6. We'll say 6 here and 5 here and about 25 here. All right. Where am I going to next? 20? All right, let's go to 20. Okay, let's give it a minute. We'll switch over to sideband. See, just that little waft of air is taking the heat sink down to 177 degrees. So, I've had people ask me several times, how do you know how to tune? And I'm like, just a lot of years of doing it. I've been tuning up amplifiers in some form or another since I was probably 13 years old. I'm in my mid 40s now, so I've got, well, over 30 years worth of experience at turning knobs on the front of an amp. And it's like, I do it, this would be my 5th amp I've done in the last 4 days. Right? So, just experience and knowing what this grid meter is absolute. I got to pay attention to what my grid meter is doing. I can't ignore that. Hello, 1 2. Hello, 1 2 1 2. Full output. Let's go to 15. Put some AM stank on it. Here we go. Oh, it's not happy. 15. Oh, and sideband. Go to AM. There we go. Once you figure out another rule, is that the lower you go, the more capacitance the circuit needs and more inductor it's going to need on the tank. You can predict where you're going to be, right? So that means you're going to be in the long end of the tank coil on this side for, let's say, 80 or 160, and your capacitors are going to be almost completely fully intermeshed. Now, how this amplifier works is we're tuning the tank coil, but The tune to the plate tune is done with a series of doorknobs that are on a big rotary arm here that Henry is famous for. They're in everything. The three other Henrys I got here, they've all got the same sequence of events. The lower you go in ding, 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 the lower you go in frequency, the more capacitance it adds to the circuit. This is fixed, so then you tune the inductor to the frequency. So, there it is. One, two, one, two, one, two. And as through this whole thing, hello, 1 2 1 2 1 2 1 2. No input schwur whatsoever. Okay. Now we're gonna go to the ham bands. For legit, like we're gonna go to the 10-meter band now. No funny business, okay? Listen. I don't care where you talk radio. As long as you do radio. Real close to right there. Sideband. Hello. No. Hello. Hello. 1 1 1 1 1 1 1. Menu. Meters. There we go. Hello. 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. 10 meters is the only band that gives me a little bit of gruff. And what I mean by a little bit of gruff is still well within acceptable standing wave ratio, right? Once again, we're looking at the SWR bridge in the radio. Hello. 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. See, then I question that by looking at the $500 worth of bird meters that are sitting right next to it with a 5-watt slug that's well within its frequency range in reverse. Hello, 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. I say the inductor's just off by a hair. Well, now we're going to let it cool down for a minute. There's no fan. So flip the switch and come back over here. We're going to monitor our high voltage. And I really want to see if I can re-zero this display and bring it back zero. Because I'd love to have this thing just be minty mint when it leaves here and perfect. And it ain't happening today. 185, 190. Amazing. No fans. No loud worry noise. I mean, hell, the loudest thing in here is the power supply on the floor. This thing's cool. I don't like how they designed it so that most of the architecture hangs on the case, but this thing is actually really neat. It's just another one to go on the annals and the archives. Just another one we got covered, right? Okay, so you guys see this little tube, or this display? It's not a dot matrix, it's none of those things. It's a friggin' tube. Be careful where I stick my hands here, I don't want to get electrocuted. It's a friggin' tube. So, we're not going to recenter that, that's actually the way it came from the factory. That's freaking sick. That is so cool. Well, I gotta apologize. I forgot to turn my lapel mic on this little segment. The amp's already packed up and put away. It's wrapped up in plastic, and it's not worth digging it back out again. I just show in the segment where I go and I put new screws in the interlocking portion of the amp, and I oiled all the little bits that move with, you know, like sewing machine oil, something that doesn't have a lot of solids in it. and I talk about how there's an access panel on the bottom of the amp that if you remove 6 screws, it allows you to have access to the rectifier, the bottom half of the rectifier ring. Over in the top corner of the amp, if the amp's facing towards you, top front, is a diode bridge. And that's 1/2 of the rectifier pack. Well, if you flip the amp up on its side, there's a little access door on the bottom that allows you to have access to the inside guts to where you can get to the other half of the rectifier ring without having to take the whole amp apart. And then the other thing I showed you is that I test the ALC and that the adjustment works fully on it. So I apologize. I simply forgot to turn on my microphone. Anyhow, back to the video. I just did a quick Google search. There is exactly 3 pictures of this amplifier in all of Google's search history. Count them, 3 total pictures. And 0 YouTube videos. That's how rare this little amplifier is. And I'm telling you, this thing's little. It's probably 2/3 the size of an SB220. This little guy is phenomenal. And it's in perfect working order. There are no dents. There are no dings. There are no scratches. Might be a little bit butt heavy, especially to this corner. And I'm really quite grateful I got to work on one, play with one, and do an overview. That way it's there forever. You guys will always have this as a reference to come back and look at. So, on that note, I don't care where it goes, but it can't stay here. It can't. The tubes are worth more than the amplifier. Hands down, that's the bottom line. The amplifier is pretty neat and unique, but the tubes that are in this thing are retardedly expensive. But that doesn't mean anything to me. I'd rather see this go to somebody that's going to use it and appreciate it for what it is, or maybe even throw it up on the shelf someplace. But to strip it apart for parts, I can't do that. This is like, it seems like I say this quite often because of the business I'm in. I'm quite lucky to enjoy the, hey, this is like a one-in-a-lifetime opportunity to be able to have access to it kind of thing. And I say that often, and often. I don't know if it's because people want to send me their stuff to, I don't know, for me to do these little videos with it. I mean, there is no blemishes, not even in the paint. Every time I think I find a scuff, come to find out I just take my thumbnail and goes, whoop, it flops off. Look at this. So, an honest number on this thing, I think fair, before shipping, is going to be $2,800. It's got the paperwork. We got the original box, most of the original box. We got the box itself. We got the original styrofoam base for this thing to sit in. This will be crated, and this will come to you inside of a minimum of 2 inches of foam packing material inside of a wood crate, because it's such a rare piece. It's a neat girl. You guys know the drill. You know how to get a hold of me. If you're interested, or you want to take it, give me a call, shoot me a text. But gentlemen, that's it. The Henry K-2000. And really the only one left that I haven't worked on or had here is the Henry 4K, the Henry 5K, and the Henry 8K. But give me time. Shout out to Siglant, McMahon, Excess Power, Bird and Coaxial Dynamics. Gentlemen, I'll see you. Click, click. And by the way, thanks to all of you for all the kick-ass projects. And a big thanks to all the Patreons. See ya. Click.